Hello viewers, welcome to this next lecture on the MOOC course on mathematical portfolio theory. You would recall that so far in the mean variance framework, we talked about how to optimize a portfolio, and we talked about efficient frontier, and we dwelled upon two important lines, namely the capital market line and the security market line, which is also known as CAPM. So, in today's lecture, we will conclude our discussion on the mean variance framework with a particular topic, namely the performance of the portfolio and how to analyze that. So, accordingly, we will look at various measures or ways or the classical ways of measuring how a portfolio is performing, and then we will see that how they are sort of related to each other and can be obtained as transformations of each other under some specified circumstances. So, let us start off our discussion on portfolio performance evaluation. Now, in order to motivate this, let us just talk about mutual fund returns. So, mutual fund is sort of the most commonly used term or the most familiar term that you can get to a portfolio. So, accordingly, I start off with this and state the following, that the returns from mutual funds are computed from their net asset value per share, and the net asset value is abbreviated as NAV, another term you might be familiar with. And a portfolios, so I have to define what is the NAV. So, a portfolio's NAV per share of the mutual fund at time t is defined as NAVT is market value of all assets at time t, and that means the all assets in the mutual fund minus portfolio's total liability at time t divided by the total number of shares outstanding, and by outstanding I mean that they are being held by investors at time t. So, this is a very simple concept, that the NAV is essentially the current valuation per share of the mutual fund. So, when you buy a mutual fund, you basically buy the number of units of the mutual fund. So, then it is given by the market value of all the assets, that means the actual value that you will get if you decide to liquidate all the assets that are in the mutual fund, and minus the portfolio's total liability. So, whatever liability you have at time t, you subtract them to the total assets that are being held in the portfolio, and then this means that this is the net amount of money that the mutual fund actually has in case it is liquidated, and or in case it decides to sell off the assets, and this is basically the current valuation at time t. And then this valuation, that means this is the value of the assets, and then this is the this value of the assets is essentially in the ownership of all the people who have purchased units of the mutual fund. So, that means for per unit of the mutual fund, you have to take this total amount and divide it by the number of mutual funds that are still outstanding or being held by investors, like small investors, financial institutions, and so on. So, this will give you basically the valuation of the mutual fund per unit of that particular mutual fund. Okay. So, now accordingly, the holding period. So, remember that at the end of the day, we will make the evaluation of the portfolio in terms of how it is performing, driven by the basic motivation that an investor invests in risky assets with the intent of maximizing their terminal wealth. So, accordingly, for the holding period return, so the holding period return, which is often called HPR, is defined as HPRT. What is this going to be? This is going to be, the return is going to be NAVT minus NAVT minus 1, that means the change in the NAV in the time period, plus DT plus GT divided by NAVT minus 1. So, this means that if the valuation of the per unit of the mutual fund at time t minus was NAVT minus 1, and then it becomes NAVT at time t. So, that means the return exclusively from its net asset value is going to be NAVT minus NAVT minus 1 divided by NAVT minus 1. However, we need to account for certain other things, some other income streams that can actually come in between time t minus 1 and time t. So, for that we have two terms dt and gt, and I will explain what these terms are. So, here your dt is disbursement, that means the payout by the mutual fund in the, so disbursement of interest in the book value of the mutual fund, and GT is essentially disbursement of capital gains realized when securities are sold for period t. So, this disbursement, this also I specify for period t, and this is not only interest, it could also mean dividends. And this NAVT minus NAVT minus 1, this is the change in the mutual funds NAV for time t. So, this is the unrealized gains or losses. So, just to go through this again, see NAVT minus NAVT minus 1, it is going to be the change in the mutual funds NAV in the intervening period t and t minus 1, and this difference of valuation comes as a result of the assets that were held at time t minus 1 and are still being held at time t. Now, between time t minus 1 and t, there are two types of incomes that can come. One is that the dividends being paid on the assets that are being held by the mutual fund in case it is a stock, or interest in case it is a bond. So, they are going to pass this on to the investors in the mutual fund, and that is what is known as the disbursement of the interest or dividends, and this G of t is the disbursement of capital gains as a result of selling of some of the assets between time 0 and t minus between time t minus 1 and t. So, this means that between time t minus 1 and t, three things can happen. Either you will get some interest or dividends which is reflected in the term dt, or some assets are sold, in which case you have a capital gains or loss which is indicated by the term gt, and then of course, assets that are still being held, and then the difference between these two as a result of the market movement between time t minus 1 and time t is given by NAVT minus NAVT minus 1. And this again, so these three income streams as a proportion, namely these income streams of NAV t minus t minus 1, dt and gt, the sum total of this as a proportion of the NAV at the beginning of the period can be reconciled to get the definition of the holding period or a single period return on the mutual fund. Alright, so now we come to the portfolio performance analysis measures, and we will essentially look at primarily three measures. So, let me start off with these measures which are known as single parameter portfolio performance measure. Okay, so I will begin with a little bit of a narrative on this. So, the more sophisticated approaches to analysis of performance of investment portfolios takes into account both the rate of return and risk from the portfolio. So, this means that this portfolio performance measures again are presented in the paradigm of the mean variance framework, namely that you look at what is the rate of return and the risk and reconcile them to find an indicator which will give you a mechanism of choosing the performance of different funds or portfolios and make a judicious decision as far as the investment is concerned. So, accordingly, driven by this mean variance framework, three individuals, namely William Sharpe, Jack Trainer and Michael Zen, have developed models for performance measure that simultaneously includes both the pillars of the Markowitz framework, namely return and risk, while at the same time allowing for rankings in terms of desirability of portfolios. So, this means that these three individuals came upon with certain ways of measuring the performance in portfolio. This is based on the return and the risk, and in this case the risk could mean both the standard deviation or the beta, as the case might be, and we will see the corresponding cases for sigma p and beta p and how it is being used. And the reason for doing this is that it will basically gives a way of or a single point indicator of evaluating the performance of the portfolio with the intent of ranking them in terms of desirability from the point of view of investment. So, we start off with the first of this due to William Sharpe, and this is what is known as Sharpe's reward to variability ratio. Okay, so what the motivation for this is that the Sharpe subtracted from each fund's average or the expected rate of return denoted by ERP, or in this case we will just write RP bar. This is the expected return on the portfolio, an estimate of the risk free interest rate, which you have already defined as RF. Now, this difference is called risk premium or excess return. So, as already highlighted, this difference of the expected return on the portfolio, which is actually a risky portfolio, as compared to a risk free return that you would have gone by just investing in a completely risk free bond such as a government bond. This additional difference is an indication of the gain that you expect to make, because as an investor you have chosen to take the risk instead of choosing a more safe path of making your investment in a risk free asset. So, however, coming to the drawback that prompted Markowitz to introduce the mean variance framework, that this difference is not exclusively enough to indicate how the portfolio is performing, because lot of times it might happen that this difference, that means the excess return that you are getting, might be accompanied by a commensurate amount of a high level of risk. And that is the reason why all these measures are driven by the mean variance framework, which takes into account both the return and the risk. So, we now have to look at a certain a little bit of an extension of this, and not just confine ourselves to the risk premium or the excess return. And accordingly, what Sharpe did was, then he divided this risk premium of each portfolio by the standard deviation of its returns, namely sigma p. So, this sigma p is essentially the risk measure of portfolio's total risk. Thus, the Sharpe's index, or sometimes it is called the Sharpe's ratio, is defined as, so motivated by this, it will be SP for Sharpe, and first we take the risk premium and we divide it by the total risk, and this is Rp bar minus Rf on the numerator divided by sigma p in the denominator. So, thus to interpret this, so thus the Sharpe index or ratio, so we will use the term index or ratio interchangeably. It combines both return and risk into a single index number, namely S subscript p, which can be used to rank investment alternatives. So, this means that what you can do is that you can look at various investment alternatives, that means a collection of portfolios, and for each case we can actually calculate the Sharpe ratio and then use the Sharpe ratio to rank the desirability of the portfolios, and then accordingly make an investment in a portfolio or a mutual fund that is more desirable. Alright, so now let us move on to the next index due to Trainer. So, this is Trainer's reward to risk ratio. So, what Trainer did was he suggested regressing the holding period return recall that this was HPR from mutual funds denoted by sigma p onto returns from the so this is actually RP. So, it suggested that you regress RP onto returns from the market index whose return is denoted by RM. So, this is the same framework as the single index model. That is, he suggested the model. So, it is a single index model. Now, I am just modifying this for a portfolio P instead of an asset I. So, RPT plus alpha P plus beta P RMT plus epsilon PT for T is equal to 1 to all the way to capital T. Where as before your alpha P and beta P are intercept and slope for the portfolio P. So, this means that it is these are the intercept and slope resulting from regressing the return on the portfolio onto the return on the market. All right. So, now let us talk about beta P, and beta P by definition what is this going to be? It is going to be the covariance of the return of portfolio with that of the market divided by sigma m square, and this is covariance of return on the portfolio is summation Wi Rit I is equal to 1 to n into Rmt by sigma m square, and this is equal to so I can use the linearity property of covariance. So, this will be summation I is equal to 1 to n Wi covariance of Rit Rmt over sigma m square, and remember this term by definition is going to be beta I. So, this is summation Wi I is equal to 1 to n summation Wi beta I into I equal to 1 to n. So, this means that the beta of the portfolio is simply going to be the expected the weighted sum of the betas of the individual assets. So, this is very similar to the expression for the return of the portfolio, which is the weighted sum of the returns of the each individual asset. Okay, so, this essentially gives you a way of calculating what is going to be the beta of the portfolio once you have made an assessment and determined what is going to be the beta of each of the individual assets. Okay, so, coming back to trainers reward to volatility ratio for portfolio P denoted. So, naturally we are going to denote this by T subscript P. It will make use of the portfolio's beta as the risk measure. So, this is in contrast to using standard deviation as the risk measure in case of the Sharpe ratio. So, now we are going to use beta as the measure of risk. All right. So, coming back to this portfolio's beta as the risk measure, and accordingly we define Tp as being excess return or risk premium over portfolios beta, and this is going to be excess return as before is Rp bar minus Rf divided by portfolios beta, which is beta p. Alright, so let us now come to the last of the three measures, and that is what is known as the Zen Sense Measure. Alright, so like trainer's measure, Zen Sense Measure is based on the implications of CAPM. So accordingly, recall the expression for CAPM or SML. You would recall that this is the expected return of portfolio. So I am looking at this in the context of portfolio is equal to RF plus E RM minus RF into beta P. So what Jensen did was to look at this CAPM and make some rearrangement. So Jensen rearranged the CAPM or the SML to obtain the following. So what Jensen did was actually looked at the expected return of the portfolio RP bar and subtracted the expected return given by CAPM, which is RF, that means this expression on the right hand side, plus ERM minus RF into beta P, and call this to be alpha P. Alright, so now we note that the term, so there are two terms here, this is RP bar and this is the expression from CAPM. So let us look at term by term. So this first term RP bar is the actual realized, that means the actual obtained return on portfolio P, and the term, the second term, which is RF plus ERM minus RF into beta P, this term is the return given by the CAPM. So accordingly, the difference between these two namely alpha P, this is the difference between the portfolio's realized performance and the performance as predicted by CAPM. So consequently, this term alpha P measures the desirability of a portfolio P, and note that alpha P is sometimes referred to as Zen Sense alpha. Alright, so to just sum it up, what did we have? We first talked about Sharpe ratio, and Sharpe ratio talked about the excess return that you are getting from the portfolio over a risk free investment, and was divided by sigma p to indicate the extent to which this was eroded by the risk as given by the standard deviation of the portfolio, and then you could use this to rank different alternative investment choice. On the other hand, in case of the trainer ratio, the risk measure that was used was no longer sigma p or the standard deviation, but was the beta of the portfolio. And Zen Sense alpha is a measure that was designed in the paradigm of CAPM, and it basically said that they took, what he did was he took the CAPM return as given by the formula of RF plus ERM minus RF into beta p as some sort of benchmark, and then looked at the return of the portfolio and wanted to measure the extent to which the realized return of the portfolio exceeded that of the benchmark return as predicted by CAPM, and higher this positive value of so ideally you want your alpha p to be positive and as high as possible. So, the higher the value of alpha, the more desirable is the investment in the corresponding portfolio for which this alpha p has been determined. Okay, now that we have identified these three single parameter measures in order to ascertain the performance of the portfolio, let us now try to dwell a little bit on how they are correlated to each other and see if there exists some sort of an equivalence behavior in terms of the qualitative assessment of the portfolio performance. So, accordingly we begin with the topic of contrasting the three models, and by this so I will use the word models, ratio and index interchangeably. So, the Sharpe, Trainer and Zen Sense portfolio performance measure as defined above are all positive linear transformation of each other. So, basically they are transformation of each other taken two at a time under some plausible, that means it can happen, circumstances. All right. So, Zen Sense recognizing that not all assets lie on the CAPM, which is why he looked at the difference of the realized return and the return predicted by CAPM. Added a constant term that is the Zen Sense alpha p, and rewrote the SML model as what? As RP bar minus RF is equal to alpha p plus RM bar minus RF. So, RM bar here is the expected return of the market portfolio into beta p, where alpha p. So, in equilibrium I will have RP bar minus RF equal to this, which is the CAPM. So, alpha p is an additional term that has shown up which has disturbed the equilibrium as given by the CAPM. So, accordingly I can make the statement that the alpha p is an indicator or is indicative of the disequilibrium of the portfolio P. So, that means the extent to which the equilibrium as given by CAPM has been disturbed. Okay, now what we do is that now we divide both sides by beta p to obtain. So, remember that once we have beta p, so we can now relate this to the Trainer ratio to obtain the Trainer ratio, which was T p is equal to R p bar minus R f over beta p. So, this will become alpha p over beta p plus R m bar minus R f. So, this means that T p is basically it involves alpha p beta p plus constant. So, I can say that the Trainer's measure T p is a linear transformation. So, we can view this as that Tp has this linear transformation Rm bar minus Rf and then has a factor of alpha p over beta p. So, this is a linear transformation of Zen Sense measure alpha p, because remember that Rm bar minus Rf is a constant. Now, further, Sharpe's measure may be derived by noting that beta p by definition is sigma p m over sigma m square, and sigma p m can be given as rho p m into sigma p into sigma m by definition of correlation coefficient divided by sigma m square. So, therefore, we can have that R p bar minus R f, which was given as alpha p plus R m bar minus R f. This instead of this beta p. So, what I am doing is that I am just replacing the value of beta p in the Zen Sense alpha relation with rho p m sigma p sigma m over sigma m square. So, we considered a plausible circumstance that for a well diversified portfolio, rho p m is approximately 1. So, therefore, we get SP, which is R p bar minus R f divided by sigma p, will be approximately alpha p over sigma p plus R m bar minus R f over sigma m. So, notice that here this sigma m will cancel out, leaving only one sigma m in the denominator, which is here. Rho is 1 and this sigma p will be removed as a result of division. So, essentially we have divided by sigma p. So, from this relation, thus Sharpe measure SP is a linear transformation of Zen Sense alpha. So, we have looked at Zen Sense alpha and its relation to the trainer ratio and the Sharpe ratio. So, we are only left with the one combination, how to connect the trainer and the Sharpe ratio. So, finally, TP and SP can be linked to each other. Accordingly, we recall that what was Tp? Tp was Rp bar minus Rf over beta p. Now, as before, we will substitute beta p. So, what you will get is that this will become Rp bar minus Rf and the beta p is going to be rho p m sigma p sigma m by sigma m square. And this is Rp bar minus Rf over rho p m into sigma p multiplied by sigma m, which is approximately Rp bar minus Rf over sigma p into sigma m, taking rho p m approximately 1 for a well diversified portfolio. And this, you recollect that this term is nothing but S of p multiplied by sigma m. Thus, Tp and Sp are approximately linear transformation of each other. And before I forget, I just want to point out one thing, that I have assumed that the rho PM is approximately 1 for a well diversified portfolio. The reason for doing is that if your portfolio P is well diversified, the more and more diversified it is, the closer you are getting to the market portfolio. That means you are closer you are getting to the portfolio mimicking the market portfolio M, and accordingly the correlation coefficient will keep approaching 1. Okay, so now what we have is that we have now a collation of all these three results, where we took at the trainer and Sharpe ratios and the Zen Sense alpha, and then we saw that how each of them is essentially a linear transformation of the other in specific circumstances. In particular, one circumstance that we particularly identified was that for a well diversified portfolio, the correlation coefficient of the portfolio P and M is approximately equal to 1. Alright, so now we come to just one last topic, and this is what is known as the index of total portfolio risk, or which is ITPR, and the portfolio beta. Okay, so for this we note that the relationship between a portfolio systematic risk, remember that we had introduced the term systematic and unsystematic risk, beta, and its total risk, that is a standard deviation, may be seen more clearly in terms of the ITPR, and which is defined as sigma p over sigma m. So, in some sense it is an indicator of the risk of the portfolio vis-a-vis the risk of the market portfolio as given by the standard deviation, which is what is known as the total risk, or the or you can view this as the unsystematic risk. So, accordingly we recall the expression for the single index model done in the previous class, and we have sigma p square is equal to beta p square sigma m square plus sigma square epsilon p. Remember that this is a total risk, and this is systematic, and this is unsystematic. Okay, now if a portfolio P is efficient, so if the portfolio P is efficient, then its diversifiable variance, that means the unsystematic risk, must be 0. So, this means that sigma square epsilon p, this term is equal to 0. So, consequently, what do we have? So, consequently from this relation we have sigma p square is equal to beta p square sigma m square. So, taking square root, what do we have? We have ITPR, which is beta p, which is actually sigma p over sigma m by definition is equal to beta p. Okay, so so we have shown that sigma p over sigma m is beta p. There is an alternate definition for this, or approach of deriving this. So, beta p is rho p m sigma p sigma m over sigma m square, and this is approximately, for a well diversified portfolio, this is going to be 1 into sigma p over sigma m, which is sigma p over sigma m, and this is again ITPR. Right. And the reason is that rho Pm is approximately 1 for efficient portfolios, or which is well diversified portfolio. So, which is the reason why we took this to be equal to 0. Now, this entire premise of having this ITPR to be equal to beta p is driven by the assumption that the portfolio P is going to be efficient. But of course, we now have to account for the scenario where the portfolio did not be so, that is, it could be inefficient. So, accordingly, in case of inefficient portfolio, where you have not been able to get rid of the diversifiable component of the risk. So, that means the one which contains the diversifiable risk sigma square epsilon p, you will get that ITPR square. This by definition is going to be sigma p square sigma m square. Now, sigma p square is going to be beta p square sigma m square from the decomposition resulting from the single index model, plus sigma square epsilon p divided by sigma m square, and this obviously is going to be greater than beta p square. So, taking square root, we get ITPR to be greater than beta of p. All right. So, just to sum up, what we have done is that we have started to look at the concept of comparing different portfolios and ranking them in terms of desirability. And in order to do this ranking, we have identified the 3 classical measures of desirability, namely the Sharpe ratio, which is the excess return over risk as given by sigma p, the Trainier ratio, again the risk premium over the beta, and then Zen Sense alpha, which is indicative of the excess or better performance given by the portfolio in terms of return as compared to the return at the equilibrium as given by CAPM, and we concluded by talking about the notion of ITPR. So, this concludes our discussion on the mean variance portfolio theory, and from the next lecture we will start talking about the framework for the non-mean variance portfolio theory. Thank you for watching.